Mutable functions are functions that have data associated with them that changes. So here's a function with behavior that varies over time. It's a model of a bank account that starts out with a balance of $100 in it, and using a function called withdraw, we're going to withdraw money from the bank account. So calling withdraw of an amount 25 will return the balance that remains in the bank account. We started with 100, now we're down to 75. So the argument here is the amount to withdraw. The return value is the remaining balance. If I call withdraw again on 25, I'll have withdrawn from the remaining balance and be left with 50. A second withdrawal of the same amount leads to a different return value, and that's a function that changes over time. If I now try to withdraw 60, but only 50 remains, it will tell me that there are insufficient funds. So the question is, where is this balance stored? And it's going to be within the function. So the way we do this is that we create a new function using a higher order function called makeWithdraw, which takes the initial balance. And we would have to have done that before we made all these calls to withdraw. Now, withdraw is a function that has a parent frame, the makeWithdraw frame, and that is where the data will live that records the balance of the bank account that is modeled by the withdraw function. Okay, so I've told you first how to use this without telling you how to implement it. And we're going to work up to the implementation after we look at the environment diagram that we want to create. So here's the goal. The goal is to have makeWithdraw be something that creates bank accounts that can be withdrawn from, which will be represented by functions. And by calling makeWithdraw with some initial balance, I will have bound that balance in a frame. I'll create a withdraw function and I'll return it. And I'll bind that to the name withdraw in the global frame. So now each time I call withdraw, I'm going to call it by introducing a new frame where the parent frame is f1, because that's the parent of the function. And therefore it will have access to the balance. And it can do what withdrawing does, which is to reduce the balance by amount and return the remaining balance. So the balance will be stored here in the parent frame f1 of the withdraw function. And it's within this parent frame that will contain the balance, or the local state of the withdraw function. And by local state, I mean the information associated with the function that is particular to that function, but might change over time. Every call to withdraw will introduce a new frame, but a new frame with the same parent, and it will decrease the balance by some amount. And the amount is the amount that's passed in to withdraw when it's called. And all the calls to the function have the same parent, so they share the same balance. And that's why the withdraw function can represent a bank account that changes over time. Now, how do we implement this? Well, we're going to need an assignment statement in order to change the balance, but it will be a special kind. So first, let's review what happens when we use an assignment statement inside of a function. What happens is that assignment binds names to values in the first frame of the current environment. So normally, when you have an assignment statement inside of a def statement, that's going to bind the name difference inside of a frame for percent difference. So here we see that percent difference contains the name difference, which is computed as the absolute value of x minus y in this case, and then is bound in the first frame of the current environment. Because this is an assignment statement, and the execution rule for assignment statements is to evaluate all the expressions on the right of equals from left to right, then bind the names on the left to the resulting values in the current frame. Okay, so our assignment statement as it exists today can only affect the current frame. It cannot affect the parent frame. We need a new kind of assignment statement to do that. It's called non-local assignment, and it enables persistent local state. So here's the actual implementation of makeWithdraw. it takes an initial balance. It returns a withdraw function that starts with this balance. And so in order to return that function, it defines withdraw, which takes in some amount to withdraw. It declares balance non-local. Now this statement, non-local balance, is a new kind of statement. What it says is that changes to the name balance will happen in the frame for make withdraw instead of in the frame for withdraw. Now for the logic of withdraw. If amount is greater than balance, then you're broke. Return insufficient funds. Otherwise, balance is rebound to balance minus amount. And then we return the balance, because that's what withdraw does. It returns the remaining balance after amount is deducted. And then from make withdraw, we need to return the withdraw function. So there's one new line here that's different from before. It declares the name balance non-local. And we tend to put non-local statements at the top of the functions in which they appear, although that's not strictly required. And what it does is it tells you about all of the assignment statements that will happen to balance from here on out within this scope, that they will change bindings of balance somewhere in a non-local frame. So what happens when we actually get to the assignment line is that it rebinds balance in the first non-local frame in which it was bound previously. So let's say you call make withdraw, and then you call the function that comes out, withdraw. Balance will be bound in a make withdraw frame, because balance is a formal parameter of the make withdraw function, here inside the parentheses in the def statement header. So that's where it was bound originally. And the rebinding that happens when you say balance equals balance minus amount will happen in the first non-local frame in which it was bound previously. So let's take a look, first at the environment diagram and then at some code. So here's the same implementation that I just showed you. Creating with a withdraw function means calling make withdraw, which introduces a new frame where balance is bound to 100. The body of make withdraw defines a new function and returns it. And that new function is bound to the name withdraw in the global frame. Now I'm going to call withdraw, which introduces a new frame. Balance is currently 100. We declare it to be non-local. We check if amount is greater than balance. It's not. So we don't execute this return statement. Instead, we execute this assignment statement, which reduces balance from 100 to 75. Now without non-local, this would be a statement about balance in the current frame. But since there's a non-local statement, this balance rebinds the balance in a non-local frame, the one that's a parent of the current frame F2. So which frame do you go to? Well, you go up the chain of parents, from this parent to this parent, etc., until you find the first instance of that name you're rebinding. So balance gets changed to 75, and then 75 gets returned. Okay, so we make another call to withdraw, and balance gets changed to 50, right there, from 75 to 50. So what's really new about this example? You could always refer to the current value of balance from within the body of withdraw, because you could always look up names in a parent frame. What you couldn't do before is change them. Now you can change the values bound to names in parent frames, but to do that you need a non-local statement. So here's that same implementation one more time. If I create a function called w by calling make withdraw on 100, w is a function that when I call it, it deducts 10 from the current balance, assuming the argument I pass in is 10. But I can pass in a different argument if I want, and now we're all the way down to 50. Now, 50 isn't a whole lot. If I try to withdraw enough to buy a new car, I will have insufficient funds. But I can still withdraw another 10 and get down to 40.